Okay, so to wrap up this particular section and examples of quadratic functions and their optimization, we're going to take a look at data. And just like what happened with linear data, where we can ask the calculator to find the best linear fit, we can actually do the same thing with the calculator. When we invoke the calculator, it's going to give us a function that is in general form. Okay, so it's going to tell us what the A and the B and the C are when we actually invoke it to do that. So here's how that happens. So first, we're going to bust out our calculators, right? And the first thing I need to do is to enter the data. So we're going to do that by opening the stat feature, and we're going to edit, and we want to put in L1 the X data, so -6, -3, 0, and 6. So there's all my X data. Arrow over, and my Y data is -10, 0, 4, 2, oops, and -6. Make sure I did that right. Okay, so there's my X and my Y data. The next thing we want to do is make sure that our statistical plot is on. Right now it is off, so just press second and Y equals, and that'll get the stat plot on. To highlight that, we'll press enter. Let's press enter to turn it on. I want a scatter plot, L1 and L2, and we're going to use the little squares. So when I go graph it, there's basically my statistical data being plotted. It fits really nicely on my standard linear rectangle. So there we have it. Does that look like a quadratic? It sure does, right? I think we tried fitting a line to it and had a little bit of problem, but it definitely looks quadratic. So how do we find the quadratic fit to this? So we go to stat menu. This time we're going to calculate. And rather than a linear regression, what we want is the quadratic regression. So when I press enter, right, I want L1 to be in the X data, right? I want L2 to be the Y data, right? And clear frequency list is no big deal, but in the regression equation, we actually want it to store our regression analysis. So we're going to press alpha and F4, the trace feature, and let's just put that in Y1. So when it's done, it's going to store the function in Y1. And then press arrow down, press enter to calculate, and there you go. Now the calculator is going to give you things in decimals, but I think we all know a repeating 3 decimal means 1/3. So our model is -1/3 x squared plus 1/3 x plus 4. And it's already stored in the calculator, but that is our model. Okay, so let's do some algebra now that we've done that, right? What I'd like to do is use the regression equation to find the vertex. We're going to do it by hand, and then I'll show you how to find it with the calculator in a moment. So to find the vertex, we're going to use our vertex formula. So h is -b over 2a. And so b is 1/3, so we have a -1/3, and a is -1/3. And so a negative divided by a negative is a positive. A 1/3 will cancel out with that 1/3, and we're basically left with a half. So my vertex is occurring at an x coordinate of 1/2. Dang it. Okay. What about my y coordinate? Well, k is the function evaluated at that value. So plugging that in, yes, we can do this with fractions. Okay, you don't need your calculator. So 1/2 squared is 1/4 times -1/3 is -1/12. 1/3 plus 1/2 is 1/6, and that's 4 over 1. My common denominator is 12, so this already has it. That's 2/12, and that's going to give us 48/12. So adding this all up, we get 48, 2 is 50, we get 49 over 12. So there is my vertex. So 1/2 and 49 over 12, which is just a touch over 4, right? Because of 12 goes into 49 4 times. That's like 4 and 1/12, and that's obviously 1/2. So there's our vertex doing it by hand. So let's go back to the calculator. All right, let's get the calculator back involved. We're going to go to y equals because we like to graph this. And again, because of my choices, it's already stored the regression equation in y1. So all I got to do is press graph. There's my data, and there's my regression curve, and it looks like a spot-on perfect quadratic. So that data is definitely quadratic in shape because we have a nice perfect quadratic to it. So let's check this to see if we have the vertex. There's two ways I can check it. Since I've already found it, right, how about we just go to calculate, right? So second trace, we want to put in a value, and the value we want is 1 divided by 2, right, a half. And what it gives us is a value just a little bit over 4, 4.0833. So I imagine if we went back and it said 49 divided by 12, there you go, 4.0833. So we did, in fact, find the vertex correctly. Now, another way to find that vertex, here's something that's new to you guys. Let's go back to that graph. We're going to actually use the calculator to find that maximum. And we'll be using this quite a bit when we move back to 3.6. So to find that, I'll go to Second Calc, and there's an option that says maximum. So go ahead and highlight it and press Enter. What it asks first is for a left bound, so my cursor's sitting right up in there, and so I basically want to move. How about I just left arrow? Notice how my cursor, oops, let me get out of the way. My cursor is moving to the left, so anything to the left of that high point is good, so just press Enter. And now it's asking for a right bound, so we'll go to the right. So I'll just move my arrow, move it, I'm definitely over to the right of it. And then it asks for a guess, so we'll move our cursor somewhere close to the high point, and then we'll press Enter, and it'll actually return that high point. It's estimated, so we know this to be a half. Because of the estimate, there's this little, 0.0000144, but it's close enough. So this is a half, and there's our y coordinate of 4.083, which we know to be 49 over 12. So that's probably a new skill for you guys, is using the calculator to find the vertex, and that verifies what we did by hand in terms of finding the vertex. I think the last question that I'm asking, so we've done this one and this one, use the regression model to predict the value at x equals to 2. So again, all I got to do is come to my calculator, press second trace for calc. I want it to find a value, so press value, and I want x to be equal to 2. And so when I press Enter, we get about 3 1/3, right? So that's what our model is basically giving us for this particular thing. So there's your quadratic regression analysis, the old school way of finding a vertex, the new school way of finding the vertex using our calculator, and then using it to find some predicted values. So it's just pretty much the same stuff we did with our lines. It's just that now it's a quadratic and a little bit more to consider. So one more example, and I think we're done. I'll try to be a little bit more real life in our next example. See you guys then.